Wanting to thank all of the supervisors who've done a lot of hard yards in guiding their internship students on the projects. So the way this scheme works is that various Curtin academics nominate projects, and we then advertise them to the students. Students apply, and this year we were fortunate to have 9 scholarships available. So they're not working for free. They do actually receive a scholarship to support the project over the summer break. I mentioned Curtin Institute for Computation. They've been supporting this scheme from the start with usually 2 scholarships each year. And Andrew Roll said he might pop in at some point, who's the director of the Curtin Institute for Computation. Our industry supporters and sponsors this year are the State Library of Western Australia, and we've got some people here from the State Library, Western Australian Museum as well, and they've been, both State Library and the Museum have been supporting the internship scheme for quite a number of years as well. So in addition to the demonstrations that will be occurring around the room after the presentations, there's also the exhibits out in the gallery. Now the gallery opens at 10 o'clock, so don't wander out there just yet, apart from the fact that there are some presentations that you should be listening to. But immediately outside in the hall here is an exhibition about HMAS-AE1, which the Hive team were involved in the tail end of that project, or the tail end of that story. HMAS-AE1 was Australia's first submarine, lost in World War I. It was discovered December of 2017, so what's that, 14 months ago. And then we participated in a survey of that wreck site off the coast of a town called Rabaul in Papua New Guinea in April of last year, and collected about 8,000 images of that wreck site and generated a full digital 3D model of that site, and that's what's on show out here. In the atrium there's an artwork based on the silhouette of the HMAS-AE1 using book covers from a library at the Army Museum that was being disposed of. So that's quite a bold statement out in the atrium walls. And there's a new exhibition that only opened last week in the South and the North galleries that's called Refuge. Please have a look at those, whether it's during the lunch break or immediately after each of the talks. The afternoon session will start at 1 o'clock. Talks will run until about 2:40, and we'll have a short break and then have demonstrations in here, and then we'll be wrapping up roughly around 4 o'clock. The morning and afternoon sessions are separate registrations in Eventbrite because some people can make the morning and not afternoon. So if you're intending to attend the afternoon and you haven't registered yet, make sure you do, just so we can keep track of numbers. We do have a limit of 50 bodies in here at one time. I mentioned that we're streaming this, so we'll post the link. If Wesley can email me the link, I'll tweet that. I should also acknowledge the students. They've been working really hard over this 10-week period, and in addition to the talk here, they'll also be submitting a report. So if you're interested in further information about the project, by all means speak with each of the students about their work and ask them about their report as well, and either they can send you a copy or we will. It'll be a few more weeks until those are ready for release. The supervisors will review it, and then the Hive team will look at it as well, and then we'll be ready to put it up there. Also need to acknowledge the Hive team who've been supporting all of these students in the visualisation aspects of the projects. So the academics around the university provide the discipline expertise, and then we just trail on the backside and provide the visualisation assistance. So Wesley in the back is running the camera, Michael on the back corner here, and Susanna as well. Thank you for them. And I'm 12 seconds ahead of time, so that makes things good. So our first presentation will be Lauren Found, who's the joke title of this is Picking Faults. So Lauren can explain further, and we'll pass over to you.
Does that work?
Yep.
Brilliant.
So you will run this rather than the tile display? Or?
I would prefer to run off the tile display.
Okay, so
And the C drive. Is that one yet?
that one?
Yep. Perfect. Is the clicker going to work?
It won't work on that, so you need
Okay.
to use this.
Not a problem. Thank you. I'll wait for a person. Good morning, everybody. My name's Lauren Found, and my project is on the application of automatic horizon picking software to seismic interpretation, which is a mouthful, hence its shortened name, Picking Faults. Is it going to work? There we go. A large component of all science is visualization, whether we take something that we see, i.e. complex folding in a mountain, and figure out the forces and the how and why of that formed, or taking invisible forces that we can't see, such as magnetism, and creating complex models, or even simple experiments like iron filings and a magnet to visualize them. This is no different when it comes to visualizing the subsurface and the rocks beneath our feet. And for this, we use a wide range of geophysical surveys. The catalyst for a lot of our visualizations has been computers. As computers have become widespread and very, very powerful, the ability to process and visualize all our rocks beneath the ground and everything that formed them is also rapidly developing. And this has really good scientific and economic benefits. As us as geologists, we can view the subsurface, analyze everything, and get a really good understanding of the how and why the system formed and why it looks the way it does. And then because of that, we can also do accurate drilling and really, really good subsurface characterizations for things like petroleum, ore bodies, any resource that we use. I had, wrong mouse. I had three main objectives in this project: to visualize the 3D data in a program that we use really often here at Curtin, and to visualize that same data again in different programs that are little used, and then to focus on how easily they work, how easily they can pick, which I'll explain later, their overall visualization, and just ease of use. This here is two representatives of the same surface, the seafloor, in two different various presentation techniques. This one here shows us time on the left, then the one on the right shows us edges, which can be a helpful feature for faults. Now, the reason is why the Hive, we can do geological analysis on any old workstation. Long story short, the answer is detail. On my normal workstation, we can either look at a large area to understand the regional trends, but we lose a lot of the detail, or we can zoom in and look at a little part of the section, but we can very quickly lose sight of what we're looking at. I've got no compromise here in the Hive. I can do both at the same time. The survey area that I'm working with is in the Exmouth Plateau up in northwest Australia. It's part of the region that's known very well for hydrocarbons and natural resources, and it's one of many basins that formed in an extensional setting in the Jurassic period 190 to 140 million years ago. The area I'm looking at focuses on a large-scale fault block that manifests as a high-rise compared to its surroundings, and because of this we can see a lot of features of a fluvio-deltaic sequence, which is a series of rivers and deltas that continue all the way down to the sea floor. So the survey area I'm focusing on is this part here under the ocean down to the bottom of the sea floor. So this sequence represents the Legendre Formation, a fluvial deltaic sequence, Jurassic in age, that starts off as mudstones and very fine-grained rocks and coarsens up to nice big sands that we use. In Petrel, this is my workflow, very, very generalized. It's made up of 4 main stages. We've got the red, which is data input, the green, which is my interpretation, which is my picking, and then we go to the yellow stage, which is analysis using attributes to understand the geology, and finally, visualization. Now, this slide doesn't like me. Here we go. The first stage of it is picking, so we then take a raw seismic section, and I then analyze all the notable horizons, which are just reflections in the rock. So seismic sections are based off of reflections, and when we have a nice big contrast in the properties of the rock, such as a change in type or velocity, we get a nice bright line across our entire section, which I can then go click through and pick. The picking, I used 3 different types because of the complexity of this area. There's a guided 3D where I can pick a point, and the program then calculates and tracks outwards in all directions to figure out and find a similar signature. Now, this can be very difficult in areas of high deformation, which I've got here, and we can see in these images on the left up around the edges of my high rise. So to conquer that, I use a guided 2D or a manual pick where I pick 2 points and the program calculates the most logical path in between them, or fully manual in the case where that doesn't work, where I just pick 2 points and it draws a straight line between them. This is all done for later stages where we can calculate surfaces and tie things together really nicely. I can then view any of my notable reflections in 2D or 3D. This picture here represents my unconformity, which is a gap in the geological rock record, in this case of about 30 to 35 million years, as erosion has broken down these rocks and we have basically no history of what happened. And because it's an erosional surface, it's very difficult to pick around these edges, which is why I've got these big black gaps. I can also pick faults. So faults in the rock are discontinuities. So when you have a nice normal sedimentary rock, it's nice and horizontal. If you then subject that to stress, it breaks and you have big displacements and discontinuities in the rock. So I can then track those as these vertical lines running down, and these ones here, which I can again then view in 2D or 3D to show their shape, how they relate to other horizons, their dip factors, and a whole other range of geological properties. Once I've done all the picking, I was then able to interpolate all the gaps, which filled in a lot of the details, such as this one here. We've got a nice surface, no black gaps, and we can observe a great amount of details, such as floor slumps. As we can see here, we can track pathways that slumps have taken, and we can follow those in the directions. And then we also, up here, we have some nice down-cutting sea canyons, which we can see in a lot of detail. So far, all of these surfaces have been shown in terms of two-way travel time, which is the time it takes for a signal to go from the boat on top of the water down into the rocks and reflected back up to a receiver. So this shows us some pretty colors, but doesn't tell us an awful lot of information. So we can then do attribute analysis. As a seismic signal is more than just a time value, we can calculate a whole range of properties about it. Here are just 5 that I've poured up on the same surface, so we can see how differently they show. We can see values that show changes in lateral continuity, which highlights our faults, which is again really good if we're looking for petroleum bodies, which more often than not use faults as a trapping mechanism. We can also view the thicknesses between rock packages, and we can map amplitude contrasts, which show us features that are contrasting or isolated from their backgrounds. It was with the amplitude maps that I was able to very clearly see these complex submarine channels. We call them paleo channels because they just mean channels, ancient channels. So these used to be delta river systems, but they're now solid rock. And we can see them in this map here of an RMS amplitude. We can see these channels with some big branches that terminate in these fans. So this happens as you go down a slope, it hits the floor and it loses a lot of energy all at once. So a lot of deposition just goes, and that's it. We also have some sub-parallel little gullies which could represent a whole lot of things. They could just simply be the current flow. They could also represent turbidity currents, which is just sediments flowing down the slope. But that's further analysis that I do not need to do for this project. We also have these gravity slumps at the end, just these crescent moon-shaped things, which are either the start of the channels, but they could also be the end of another slope that we don't see on this survey area. This video here is showing an enhancement I ran on the channels, where I took my seismic wavelet, which is made of a band of frequencies like this, and I picked 3 values, and I blended them together. And as we view this through a section, so in this case we're starting at the bottom and going up, we can view these channels as they become more and more complex, and as these develop, and then eventually as these fans at the very end develop. So this helps us understand the evolution, and we can also figure out things like the rate of movement and why the seafloor was going this way and whatnot. So this was the work I did in Petrel. I then needed to do the exact same thing in another program, which is called Geoteric. As we've got here, I've got the same 4 major stages, but in this case, the order is reversed that I did them in. So we did the data input, but before we did any interpretation, the program is designed to do multi-attribute blends and basically provide us with a visualization of the geology before we do any interpretations. And this allows for a decrease in error and for very, very greatly enhanced interpretations. So going back to picking faults, we can do this 3 ways in Geoteric. The first stage I did was I created a multi-attribute blend which blends 3 edge detection parameters together of amplitude, phase, and dip. And this highlights the edges of our section. So as we can see in this video here, we've got our nice big folded sequence, and all these black lines running up through it are our faults. So we can see them here without doing any picking. But it's not the only alternative. We can pick if we want to. There are 2 picking methods. You can either use this one here, which is semi-automatic, where I picked the fault sticks, which we can see as these big rods. I clicked the top and the bottom, and I did a couple in the Z direction, and it calculated the rest all for me. This took me about 5 minutes each, and it took me about 12 clicks and manual interpretations from me, whereas to do the same thing in Petrel, it took me about 100 clicks. So we're representing a huge increase in efficiency and time and understanding. We can also run a complete automatic picking, such as this one here. I did nothing on this. I simply said, look at this, then go. And it's picked all these faults for me in the green. But it also does highlight noise, which is unwanted signal, because I didn't run a noise filter on this. And we can see that it is prone to noise. We can filter those out, but that does filter out a lot of our signal as well. But if I had to say a recommendation, I think just the simple CMY blend by itself without any picking is great, because you can truly see how complex the faults are, because they all start in this direction, but as we go further down, we've got different directions, and that would just take years to pick manually, whereas this one took about 45 minutes. Following the CMY blend, I then did a couple more, where we can do a frequency decomposition again, like I did in Petrel, but this one was really good because it generated a spectrum for me. So I was able to literally look at my signal and go, those are the frequencies I want, whereas in Petrel I guessed them. What I could then do from there is drape them on slices that I calculated using my boundaries in Petrel. I imported them in, calculated the distances between them, and it ran all these surfaces nice for me. And we can see this is again my sea floor. As I was mentioning with these slumps moving earlier, we can see them here, and they almost look like oil slicks. And that's just the way that the program is blended. And we can also see these canyons that I was mentioning. This is my edge blend that I also use for the faults. You can see them all running here in nice parallel black lines. But we've also got these really nice down-cutting canyons, which are in extremely high detail, and we weren't able to see in any other program. And then again with the paleo channels, once I found them in this program, because of the ease and rapid nature of the calculations, I was able to do the whole process again just on this surface. And this highlighted everything for me in such great detail that I don't really need to squiggle on that to show you where the channels are. but I will anyway. So this is a channel. This time we're going from top to bottom, and I didn't need to do any manipulation of my seismic volume to see these channels. As we can see here, there's my slice. It's representing a big dipping part of the surface, but the whole program has calculated this automatically for me. One other process I was able to do in this program that I was not able to do in Petrel is geobody picking. So similarly to how I was picking horizons and faults, I could do the same with my paleo channels. So I took a couple of these really nice looking surfaces, I traced the outside, colored them all in, and it resulted in these bodies that we can see individually. We can then put them in any of our volumes. So this one here on the right is my original seismic volume with the channel, and we can see its relationship to how it's deformed. We can also drape that on any of our other surfaces to view them in any way we like. There was a third program that I was going to operate using, called PaleoScan, but unfortunately due to license constraints, I was not able to complete my work in time to a sufficient quality. So this leads to the future. What can I go from here? There is quite literally infinite potential. I scratched the surface with what these programs can do. I scratched the surface with the survey area that I'm working in. But there are many other features and geological settings that exist that I can work in. So these examples here are the remnants of a volcano in offshore New Zealand. We can see the volcano here and over there in bright green, and it's surrounded by different fault systems because the way rocks break and deform is different every single time. There's very few ways to explain them all in one go. We also have some really nicely defined paleo channels, and in this section here we can do borehole correlations, which I didn't do any of in this project because I had no wells to work with, but we can do that, and we can use these as well as finding hydrocarbons. So these bright spots that we see all throughout my section are potential gas chambers, which we can then enhance and work with further, and we can use everything that we've done to calculate volumetrics and get an estimate of how much it's actually there, what is the chance of it existing, how much money can we make off of it. But this is many, many, many more hours of study. And yeah, so there is infinitely more potential, and I've just scratched the surface. To conclude, I'd like to thank my supervisors, Professor Chris Elders and Dr. Jane Cunning, for helping me answering all my questions, running through all the bugs and problems we had, and well, it was good fun. I'd also like to thank the Curtin Hive staff again for dealing with all these license problems and bugs, and me coming every other week and saying, I don't know what's going on, but they've been really helpful, really accommodating. I'd also like to thank Petrel, Geoteric, and PaleoScan for providing the university with the licenses needed, even if it was slightly late, but nonetheless. And I would also like to thank Peng Chen. His thesis was on the evolution of the survey area, and it provided me with so much help. So that thesis meant that I could go straight into using the program instead of spending 6 weeks learning about the area. Are there any questions? Thank you very much for listening to my speech, and thank you for taking the time to listen to me.
And to get Lauren's joke, I'm not sure if it was intentional, but scratching the surface, almost as good as my one about finding faults. Any questions from the audience?
I have a question. So I liked the presentation very much. It was a very nice one, and I don't think you scratched all on the surface. It was very deep. But how difficult is it, for example, to realize something in Petrel, and if you want to add, for example, additional features to your visualization, like little flags, tags, or whatever? How difficult is it to implement something in the system?
It's not overly difficult at all. Both systems are designed very differently. So Geoteric is very automatic, so that would be a lot more difficult to kind of flag things, but Petrel is a lot more manual, so I've done every single step individually. So to put something in, like annotations, notes, is rather simple. It took me probably, my first week, I had to look at the seismic section and analyze all the geology. It took me about 30 seconds to stick labels on where I was looking for things. And yeah, it can all be done, it can all be found very easily. It's a very simple program to use once you know how to use it.
And how would you expect the learning curve of learning design, for example? Or
So
use of it?
I had never used either of these programs before starting. I would say Petrel it took me a couple of weeks. So to do the major things is very simple and straightforward to use. You could pick that up in about 10 minutes. But a lot of the fine details, they do have workbooks, they do have guides available. And once you learn how to read them, they are very intelligently built and it's very intuitive. The way the systems are organized is if you wanted to do a seismic interpretation, there's a ribbon at the top that says seismic interpretation. You'd then click it, you'd then find what you wanted to do. And then it would, if you got confused, there was a little help icon to help you. So all in all, I didn't struggle learning how to use these programs. I hadn't used anything for 3D visualization prior to this program, and I found it very straightforward.
Are there any further questions? One over here.
Hi Lauren, that was a lovely presentation.
Thank you.
I'm not a science person, I come from health sciences, but that was so beautifully presented. My one question is, this is great to see on this kind of screen. With the program that you used, is this something that can be done in a mobile way for geologists or people working who may not be in the hive?
In the Hive, definitely. I did 99% of my work in the geology building or the applied sciences building, and it was a couple of computer screens, and it works just as well. Like I said at the start, the reason I used the Hive is because I could see this huge, huge surface with all the detail that I needed to, instead of spending time scrolling in and out and in and out and in and out to look at these overall features. So it works for all geologists. It works on any computer, granted you've got the license. And yeah, it was fantastic on my workstation as well. This was just better.
Thank you.
All right, thank you, Lauren. And just to let people know that unfortunately Lauren won't be able to join us for the demos. There's a conference going on in the city today, so she'll run off to that, but she will be running back towards the end of the day for the afternoon demos. So thanks again. Our next presenter, please come up, Isaac, is Isaac McCormick. Yeah, just put that one over there. He'll be presenting a project that's been conducted with the State Library of Western Australia. His Curtin supervisor is Artur Lugmeyer over here, along with Deb Jones and Tricia McKenzie from the State Library. So I'll pop that on you.
Thank you. And do I just change it to Isaac McCormick? Easy. Okay. Yeah, that's good. Okay. No. Hello everyone, and thank you for coming today. My name is Isaac McCormick, and I'm a recent graduate of the Curtin University's Master of Architecture program. And I've been working with the State Library of Western Australia, Artur Lugmeyer, and the Curtin Hive on the project Living Historical Documents. Today, I'd like to speak on the process and decisions made to take this project from a brief to a final product, in this case being an educational game. But first, what is Living Historical Documents, and what does it actually mean? The brief asked, how can the digital medium increase engagement with school children between the age of 5 and 12 with the primary source material, in this case being the Francis Bussell diaries. It needed to be web-based, have a high level of interactivity with the student, and use the existing resources and images and sound bites from the State Library's archives to bring the diaries alive and make students want to engage with the material. From this brief, I decided the two most important things were engagement and interactivity. When making a design decision, I would ask... Oh, okay, I can speak up. When making a decision, I would ask questions... Yeah. Okay, that's easy. When making a decision, I would ask the question to myself, does it improve engagement or interactivity? If not, I put it to one side. So to start the project, we first had to look at the source material, in this case, the Bussell diaries, written on her journey from England to the Swan River colony in the 1830s. And you can see straight away the issue with this the issue and the reason this project was undertaken. Because if you can read this, you have far better interpretation skills of 18th century English than myself, and I assume the average 5th grade student. At this point, I'd like to thank the State Library for providing me transcripts I could actually read and understand. Otherwise, the project would not have got very far over the 12 weeks. I think I'd still be locked in a room, desperately trying to make sense of the diaries. So how did we get from this diary to this educational game? To get here, I used Bernard Roberts' The Educational Uses of Digital Storytelling. This paper taught me a lot about teaching and learning concepts and how the digital medium could enhance them. Bernard outlined 7 points that I considered continually through this process. These points were, firstly, the point of view. What's the perspective of the author? That's easy, Francis Bustle. The second point, a dramatic question. A question that will be answered by the end of the story. What is it like to sail in Australia? 3, the emotional content, an issue that speaks about the personal journey of the person. That's easy. She wrote lots of journal entries, and to pick interesting ones that students might engage with. The 4th, the gift of your voice, a way to personalize the story and help the audience understand. In this case, images and the images and the art style was chosen. The 5th point, the power of the soundtrack, the music and other sounds. I'd like to thank Alison for doing wonderful narration of the diaries throughout the project. The 6th point, the economy. Simply put, it's using just enough content to tell the story without overloading the viewer with too much information. The 7th point, pacing. This is related to the economy. How fast or slowly does this information come at you? This early mind map is of my research ideas and concept. While almost as incomprehensible as the original Bustle diaries, was extremely useful to sort through the information provided by the State Library and their goals and objectives, the information provided by my supervisor in relation to visualization and teaching and learning, then filtering it through what I think I could produce in the time and with my skill set. This will enable me to view a lot of different design options and compare them and contrast them with each other. A few interesting ones that were generated this time was just a simple interactive diary with images and sounds you could click on, an AR-enabled diary where creatures and things could come out of the diary, or a simple quiz-based game. These ideas, while interesting, were cast aside for various reasons. Either it was too much for me to tackle in the time period, it did not meet the library's needs or the curriculum of the students, or it was too technically difficult for me to undertake. So a game was decided as it met with the learning outcomes needed by the curriculum, could incorporate the library's original concept for an interactive diary, and use the resources of the library, and be undertaken in the time period and with my skill set. So, why a game? What does a game offer that other teaching, that the other ideas did not, and the original diaries didn't offer either? Well, it offered these 3 things. It offered a sense of exploration and discovery beyond simply wanting to know what happened on the next page. 2, a level of interactivity and engagement that keeps you enthralled with the material. And 3, and finally, a challenge that can be used to reinforce the material that is being learned and offer a reward and sense of gratification when completed. So I'd now like to explore how and where these elements are added into the game and what I think they do. So firstly, exploration. It was a natural fit for a story about sailing to a new land. It was by far the easiest part of the game to develop, as it was essentially creating a stylized version of the coast of Western Australia and the Swan River colony. While it is completely inaccurate, it served as a base to help me develop and design the map. And when designing the map, I ensured to give each of the 4 areas a distinct feel to increase the sense of discovery, making it much like an explorer wanting to map out and understand this mysterious new land, always wanting to see what is over the next hill. Again, this was a perfect companion and fit with the diaries. To help further differentiate these areas, I used 2 distinct colour palettes. One for the ocean and coast region, which you just saw, and one for the river and inland area, which is displayed here. The switch between the colour palettes occurs at the halfway point in the game to re-engage and renew the sense of discovery and to signal a shift from sailing on the open ocean to sailing up the Swan River and eventually up the path to the Swan River colony. The decision to focus heavily on exploration in the game and making it a chief game mechanic meant the art style would need to be visually engaging, so players would want to explore more of the map. To encourage this exploration even further, I took the diaries, the original transcripts, and broke them down into 8 pages, then scattered them across the map, asking players to go forth and find the pages, becoming again the chief mechanic. placing 2 pages in each of the 4 areas, as this would allow for a decent level of exploration before the players would become bored or think the area is stale. But why is exploration so useful in teaching? Because it changes the dynamic from one of passively receiving information to one of actively seeking and searching for new information, creating an engagement that did not exist before. The advantage this game offers is interactivity. The advantage it offers is this interactivity. To help build upon this, when players click and find a page in the diary, images are displayed that come from the library's archive, and the narration of the text begin. While this narration plays, players can click through various images that relate to the entry that is being read. These images were carefully curated and selected by myself and with input of the State Library. The 2 purposes, as I said, was to relate to the diary and also to serve as a minor reward. But some of these images also serve to illustrate the strangeness and foreignness of this new land, as you can see here with this rather elongated kangaroo. It also displayed the idea that information can become distorted or twisted over time. As you can see here with the source button in the bottom of the corner, this links directly to the database the image came from. This helped to display how multiple sources can come together. This helped display how multiple sources could come together to make a whole picture or a better picture of the past. Finally, I'd like to talk about the level of challenge and how this can be used to reinforce what is being learned or read about. This system is closely tied to the exploration system, as throughout the play area there are these barriers, and when a player hits one of these barriers, a question is asked of them. These questions would relate to the last 2 pages of the diary they've read. If they can't answer it correctly, they are told to either try again or go read the passage again and search it out. However, this system is by no means perfect, as the player could just simply keep clicking until they got the right answer, and if this project is to continue in the future, I'd recommend a more comprehensive puzzle or question system be implemented, because if I was a kid, I would just click through until I got to the end. Finally, the HUD, particularly the HUD on the left-hand side, this scoreboard, it informs the players of the number of entries they have found. It acts as a sort of a marker saying there's only this much more to go, keep going, you'll get there eventually. It keeps players engaged as there's an idea of what they're working towards at the end, find all the journal entries. Again, hopefully encouraging players to seek information rather than passively be giving it. Also, throughout the game, questions appear that require no immediate answer. They just ask you to reflect on what you've read and the entries, hopefully again reinforcing what's being read about. So finally, when you find all the journal entries, you are taken here to a completed version of the completed version of the journal that you've been so diligently reassembling, as there needed to be a sense of conclusion and completion to the story. Also, this is designed to further reinforce the ideas that these were real stories taken from real people and reassembled here in a new way. There are buttons, however, that link to the original journeys, and hopefully players will want to go and find out more. So in conclusion, the game aimed to do 3 things: provide a sense of exploration and discovery through the map and art style, provide a level of interactivity through imagery and the act of searching for information, provide a sense of challenge through reward and through then reward through questions and the completed diary. I'd like to thank the State Library for giving me this project, the Curtin Hive, and Artur Langmar for giving me the chance to work on this project. Thank you all for listening, and I hope you have a wonderful day.
Any questions from the audience? Oh, here we go.
Yeah, comment on I love the design. And, they, sought to make it authentic.
Thank you.
Really impacted. I'm sure for the user it would be a real comfort to see that, and you could get into the story a lot easier. How did you come up with that sort of process? With all your notes look very interesting.
So that came from just trial and error, really. It was just working out what was there, and then looking at the project began by just looking at a vast array of what other people had been doing and how they'd sort of tackled this project. So there's like a slideshow of like about 50 different projects, not 50, 25 different projects of like this then, but they're not all related to games, but just looking at other projects, seeing what others did, and then taking my own skills in like visual design and looking at like how I could mesh them together. Questions?
Down the back, Ahmad?
In the original areas, do you have to have a specific question as well?
No, it's all, whenever you hit any of the barriers, and it's actually quite a distance off the barrier when it first appears in the screen, so players will always hit the barrier. Yeah.
Just wondering, you realise it's the summer break, etc., but have you actually had any kids try it out?
We've had one, but it was still in the prototype stage, but yeah, hopefully they'll use it. I'm really curious to see how students engage with it.
They like it? The one person?
Yeah? Yeah. Yeah.
You've got time to explain. So.
Yeah, I talk way too quick. Yeah. Yeah. Yeah.
I was going to ask about the user testing.
Okay. Yeah. Yeah.
I really enjoyed that. The journal at the end is really quite beautiful. Is that your work?
It's a combination of my floorboards in my house, images, images that I found online of like assets of like a key and old journal entries, and then I think it is an older diary that I erased all the text out of and then put my own text in and then edited it the way it looked to make it look older than it actually was. So it's sort of a collage. Yeah.
Any other questions from the audience? I had one. I was sort of wondering when I was looking at the sort of the mapping you've got, whether it would be good to sort of make it look more closely to the Perth coast and the Swan River shape. Yeah, it might provide some recognition. I don't know whether kids recognise the river from above, but
yes, that was a discussion with the point, and it came down to producing a clean and final product to getting to continuing to edit the map. But in some of the images when you are near that coast are of the Swan River, the early maps of the Swan River colony and Augusta. Mm-hmm. Yeah.
So the story is based where? Is it Swan River, Fremantle, Perth?
It starts from out at sea on the Swan River, sailing down the coast of Western Australia, then to the Swan River colony, then finally to Augusta and Vassar, where's the Bustles finally ended up.
Yep.
But most of the story ends at the Swan River colony for this portion of the game, but I think the Bustle diaries continue on further than that.
Yep. So they didn't live in Bustleton?
No. They moved to Bustleton though at one point. Vassar was the name?
Vass, I think.
Yeah, Vass. And then it became Bustleton.
Yep. So any other questions? Patrick.
Further to that, I think that, I think the idea is terrific, and that the impact of analyse at the actual show. So I think that's the crucial part of what the understanding, even for a young child to understand, is to be able to put your characters in the game into the actual context.
Yes.
Very stylized. I appreciate this time and the program, and it gives you a few components.
Yeah.
But to me, the landscape, understanding the landscape is an integral part of understanding the diary.
Yeah.
So Patrick has spent almost 100 years at the museum, not quite. So he has a little bit of insight into audience experience. But sort of partly what inspired this project is that the State Library has lots of school groups coming into the library to experience their collection, and plonking a very hard-to-read diary in front of them would be an impossibility of getting them to actually gain some valuable insight out of that. So this is an experiment to see how we can engage a student audience with this content, and I think it's a really great exploration of that.
I think in fairness to Isaac as well, you have quite a brief amount of time to do this, so
Thank you.
Okay. All right, well, thank you very much. Now, continuing the theme of old things, please come up, Erin. Erin Jackson will be exploring the journals of Franncisco Pelseart, who was the commander of the Dutch ship Batavia, which sank off the WA coast in 1629. Erin's Curtin supervisor is David McMeekin, who's just in the audience here. And this project was supported by the Western Australian Museum. Patrick's from the WA Museum, but this one was actually supervised or co-supervised by Jeremy Green. I don't think Jeremy's here, no. And yeah, so we thank the WA Museum for their support and inspiration to this project, and it's really quite a bit of a horrible history, this particular story, but Erin, I think, has survived. So try and put that on. There we go.
Okay. Hi everyone, my name's Erin and my project was transforming the journals of Franncisco Pelseart, commander of the Dutch VOC ship Batavia, into a web archive moving towards linked open data. Just to give you some brief information about the Batavia departed its home port on the 28th of October 1628, and it was on its maiden voyage to Batavia in the East Indies. There were 341 people on board, but only 322 made it to the point where it was shipwrecked, as some deserted or transferred ships, and others died of scurvy and disease on the journey. The Batavia was leader of a 7-ship fleet under the command of Franncisco Pelseart, and he spent most of the journey ill in his cabin. This caused discipline on the ship to crumble, and as it was carrying wealthy cargo, it's believed that one of the passengers, Geronimus Cornelius, tried to start a mutiny. As he was unsuccessful, the skipper, who also had well-known clashes with Pelseart's leadership, steered the Batavia off course shortly after leaving the Cape of Good Hope. On the 4th of June, they shipwrecked on Morning Reef in the Abrolhos Islands, and while Pelseart and all the senior officers went to search for water, Cornelius murdered 115 of the passengers to escape mutiny charges and reduce the number of mouths to feed. The objective of our project was to create a web interface and digital archive, and this interface should allow the scanned images of Pelseart's journals and the Dutch and English translations to exist together in an appealing manner. Additionally, it should visualise the journey taken by Pelseart and his attempts to save the shipwrecked passengers, be easily updated by museum staff, be able to be interacted with by visitors to the museum, and be processed into the semantic web through linked open data. The dataset for our project was supplied by the Department of Maritime Archaeology from the WA Museum, and this dataset contained 172 high-quality JPEG images, so one for each page in the journal, a Word document containing the Dutch transcript of the journal, and within this document, each document page contained one of the journal pages. The transcript for each page was recorded in a table, and text within each table was formatted to match the journal entry line by line. For the English version, each table only had, go back. Yeah, so, sorry. Yeah, so for the English version, each document page contained one of the journal entry pages, and the translation was stored in a table on each page. So with one column of the table relating to the date and the other column to the translation. As each table only had one row, the date and the time of the entry didn't always match. So at the bottom of each page, footnotes were added from the translator, and these footnotes provided extra information and some explanations to the translation. This format proved difficult when developing the linked open data stage of this project, as it was quite a large data set and the information could not be easily extracted from the tables in the Word documents while keeping the formatting intact. Just to give you some information about linked open data, linked open data improves the reusability, availability and interpretability of data and allows for easier integration between multiple data sources. It uses a resource definition framework to store data as subjects, objects and predicate triples, a web ontology language such as OWL or Turtle to class the elements and their properties, and a universal resource identifier to merge and map data from different resources. So those objects with the same URI can be linked together. An excellent example of linked open data is the Rijksmuseum. This museum has converted its data to linked open data through the Europeana model. This allowed over 351,000 objects within the Rijksmuseum to be available on the Europeana interface. Initially, staff of the museum had concerns about making their collection available online, as this would mean visitors wouldn't have to come to the museum. However, as they only are able to physically display 20% of their collection at once, the shift to linked open data both increased the visibility of their collection and public interaction with the museum. Europeana allows objects in the collection to be linked to external data sets, such as geonames and the Dutch art and architecture thesaurus. It also allows users to search objects across institutions, collections, formats, and countries. So this slide provides an example of how linked open data can be implemented in this project. So for example, if a document had the phrase, Franncisco Pelseart is the commander of the ship Batavia, Franncisco Pelseart would be the subject, Batavia would be the object, and commander of would be the predicate. This piece of information could then be queried in linked open data using the following SPARQL statement. So select all the predicates and objects where the subject is Franncisco Pelseart. This would return all the information relating to Franncisco Pelseart and could be used to draw out new knowledge that has not been seen before. It would also link Franncisco Pelseart into the semantic web. In order to inform users to the quality of the linked data set they are producing or using, a 5-star open linked data rating scheme is established. In order to meet the 5-star criteria, a data set has to be available on the web in a machine-readable structure, and ideally in a non-proprietary format. Additionally, it should utilise open standards from the W3C, including a resource definition framework, and should be able to be queried through SPARQL. The final star is awarded when you begin to link your data to other people's through the use of a universal resource identifier. Currently, over 1,200 datasets have been classified as 5-star datasets, with over 16,136 linkages made as of June last year. To prepare the dataset to be converted into a web archive, the following steps were taken. Firstly, the JPEG images were converted to PNG images as they reduced the overall file size without compromising the readability of the text. Secondly, I read all of the English translations on the entries and for each day recorded the midday latitude, the distance and direction travelled, and any landmarks mentioned. After reading these entries, it became clear that the journal could be divided into 4 distinct journeys. Firstly, the journey taken by Pelseart made in the longboat from the shipwreck to Batavia and the East Indies. Secondly, the return journey on the VOC yacht, the Sardam. Thirdly, the bulk of the journal that relates to the trial information, the rescue of the survivors, and the recovery of the cargo. And finally, the journey aboard the Sardam with all of the rescue passengers back to the Batavia. In order to visualise these journeys, the Leaflet JavaScript library was used. This library was chosen over other mapping products such as OpenLayers and Mapbox as it's freely available, easy to implement, and requires minimal storage space. Additionally, it can also be used on a mobile device, making it ideal for this project. Once loaded on the web page, users can select between a cartographic landscape map provided by the Thunder Forest Base Map Library or an Esri satellite map like the one used in Google Earth. Buttons were added to the top of the map to allow users to zoom in on areas of interest, such as the Batavia or the Abrolhos. Daily movements were added to the map through markers. As certain pages contain multiple days and certain days go over multiple pages, each marker corresponds to one day of the journey. When a marker is clicked, the date and corresponding journal page number is displayed. Lines between markers were then added through the Leaflet Curve plugin. Buttons were also added to allow users to add certain journeys at a time. This both increased the visualization properties of the map and the ability of the map to be interacted with by visitors. Due to the challenging format of the data, the ability to display the Dutch transcript and English translations was the most challenging to overcome. The JS timeline script developed by the Knight Lab from the Northwestern University, Chicago and San Francisco was used to do this. This script is created using a provided Google spreadsheet, meaning it's easily updatable, providing you have the link. It allows you to display both the English and Dutch translations for each journal page in one element while also being mobile friendly. Furthermore, this timeline can be embedded into the web page, meaning it requires minimal server space, and a copy of the spreadsheet can be exported as a CSV and added to the web page to be downloaded. And this meets 3 out of 5 of the linked open data requirements. The museum had additional requirements concerning the displaying of the journal images. Firstly, visitors had to be able to zoom in on the image to view the written text in higher detail. It also had to be interacted with by visitors while using minimal server storage space as possible. To do this, the Flip HTML5 tool was used. This script is freely available, interactable, uses minimal storage space, and contains a zoom feature. To embed the Flipbook into the web page, the images were combined into a single PDF document. This document was also added to the download folder on the web page to meet some of the linked open data requirements. Additionally, tabs were added to the interface to allow the users to easily flick to certain journeys in the journal. This was then run through the Flip HTML5 tool to produce a link that could be embedded into the web page. This tool was also chosen as it creates a book-like interface that allows the user to flip through the journals as if they were an actual book. Future work will implement this ability to search the text in the images, and this will allow the user to interact more with the journal. Some accuracy issues arose when placing the locational markers on the leaflet map. Firstly, Pelseart only recorded the midday latitude when weather conditions permitted. An example of this is on the 19th of June when he recorded, "At noon, did not have latitude, by account has sailed 7 miles, made good north-northeast, the wind north-east-west by west, rough weather with rain." When returning to the Abrolhos, Pelseart also started to record longitude. For example, on the 1st of August, he measured his latitude as 21 degrees 13 minutes and his longitude as 133 degrees 55 minutes. Anyone familiar with longitude would know in the current day this corresponds to the middle of the Northern Territory. So it became clear very quickly that Pelseart was not measuring his longitudes from Greenwich, which only started as the prime meridian in 1884. Because of this, we couldn't take his longitude recordings into account when determining his location. Instead, the known latitude, distance and direction travelled were used to make a highly accurate estimate of his current location. Another difficulty was when Pelseart would refer to place names that are no longer used today. This occurred when he sailed to the Batavia first time and passed through the Prince and Islands. When looking at a current map, there are no Prince and Islands near the coast of Java, so I had to look for similar place names. There are a set of islands called the Panatun Islands, which have historically been referred to as Prince's Island. It is therefore likely that these are the islands he was referring to. When a location couldn't be linked to a modern-day place name, the previous next location, distance and direction travelled were used to estimate his current location. Due to time constraints, many features that would have ideally been implemented were unable to be applied to the web page. Firstly, future work could focus on making the site accessible to all. This would include implementing text-to-speech capabilities and buttons to vary text size for those who are visually impaired. As the Leaflet CurveScript library only works on Google Chrome and Firefox, future work will aim to make the site accessible on all browsers and in all languages. Ideally, the elements on the page could be linked together, so when you click on the marker, the translation image page will change to match the day. This will allow visitors to easily compare the location, written entry and translation of a particular day of the journey. Finally, the archive will be transformed into fully open linked data to increase the availability, linkability and interpretability of Pelseart's journals. This web archive created in this project meets most of the requirements set by the museum. The leaflet element visualises the journeys taken by Pelseart, while the timeline and Flipbook can be easily updated and interacted with by museum staff and visitors. Additionally, the related web page is available both on the desktop and mobile, increasing its accessibility. Where possible, we have attempted to link the web page into the semantic web through open link data. Finally, the web interface and digital archive created in this project provides a template that can be used across various other cultural heritage data sets. So other journeys, such as the 1725 shipwrecking of the Zeewick, could be added to the web page to create a database to allow museum visitors to compare and contrast shipwrecks in the Abrolhos Islands. I'd like to just thank my supervisor, David, the Curtin Hive, and also the Western Australian Museum staff.
Do we have any questions for Erin?
Yeah.
I'll go back. Ahmad.
You mentioned the most difficult part is
The most fun part was definitely the map, yeah. Being able to, because that hasn't been done before, being able to see the journey taken was really interesting.
And that's the whole visual bit.
Yeah,
Turning
yeah.
an otherwise text-heavy journal into something visual can be very difficult. So it was great to see it and interpret it in a visual way on a map. Yeah. Any other questions from the audience? Patrick?
Excuse me. You just said it's been an important part of my life for the last 6 years. So it's really...
Yeah, it's become an important part of my life too.
6 years ago. The accuracy of estimation you acknowledge. Have you got an indicator there about probability of position, in the voyage position?
Not at the moment, no. But yeah.
I mean, it's very hard.
Exactly, yeah.
It's, having problems with things becoming, you say it's deadly for them, that's great. But the difficulty is that you see it and you say, oh, that's what happened. Because it's so clearly
No,
false
yeah.
that in fact, there's so many doubts. The major one being the arguments that continue to rage about where Pelseart actually touched the West Australian coast, because he went ashore to get water and so on. And there's a lot of discussion about whether that be. It's quite significant, of course, when you're trying to understand the journey.
Yeah.
If he came in Kalbarri or if he came in Moore River or whatever, either of those could have been. So, it's certainly something that perhaps would be helpful to have.
Yeah.
When you click on it, the debate for that
Yeah.
position.
I might just point out for the audience that Patrick has been with the museum for 46 years, not 100.
I would be if I hadn't retired 2 years ago.
Yeah. And was one of the part of the museum team that dived and recovered the wreck of Batavia, and it's now sitting at, for those who haven't been to the Shipwreck Museum in Fremantle, that's where the 10% of the hull of Batavia that remains is currently located. And so the wreck was discovered in the 1960s. Patrick and Jeremy Baker and many others dived on the site over multiple years in the early 1970s, and it's been a continuous source of inspiration and research ever since. A question over here, Gretchen.
I just had a quick question. You said that the longitude, they weren't measuring relative to Greenwich. Do you know where they were measuring?
It's not quite clear. I assume it would be somewhere in Holland, perhaps, considering that's what they came from.
Was the other main
Maybe,
meridian,
yeah.
Until the 1800s.
Well, there you go.
So it might be worth looking to see.
Yeah.
I don't know if the Dutch had their own meridian.
The way they measured it as well was also quite inaccurate. I think Jeremy from the museum was saying they used to throw a piece of...
Well, the actual figure of longitude certainly is based on a number of, but that's easy. The difficult part is that it is always an estimation. When you're on a ship at this time and you're moving and you're in a moving environment, you actually don't know where you are. The longitude, you don't have 5%. So it's all dead reckoning, but it actually, we might call it guesswork. It's based on observation. And it can be wildly inaccurate. Actually, why they kept running into Australia.
Damn.
They didn't have chronometers then, they had sunglasses. So chronometers didn't come for another 150 years.
I think Jeremy from the museum was saying that the way they measured longitude was they threw a piece of stick overboard and see how far it travelled, which, not exactly accurate.
Moving the currents, moving it.
Yeah.
You're all moving.
So there's a question over here from David.
Yeah, just to comment on that, the Ancient Itineraries Digital Geographies group has become interested in the project and some of those accuracies. So at our next meeting, there'll be a whole discussion around this kind of thing, looking at, there's some more ancient historian experts into the geographies and accuracies.
Any other questions from the audience? No? Well, that's probably a natural point to stop. Thank Erin.